Okay, section 7.3 is solving quadratic equations by graphing. And on this one, we're going to use graphing technology. So you do need to know how to graph quadratic equations with graphing technology. You also need to know how to graph quadratic equations by hand. But today you're going to get bailed out because you get to use your the online graphing calculator. So remember, I have a link to it on my page. It's this desmos.com/calculator. So pause the video, go open up that window so that you're ready to go, and then we'll go through this lesson. Okay, so it says keep in mind that a second degree equation is in one variable is quadratic. Do you remember what second degree means? Hopefully you remember it means that the highest exponent in the equation is an x squared, okay? Now it says these equations are quadratic, okay? 4x squared plus 3x plus 3 equals 0. That's the first one. Here's my highest exponent. It's a 2, so that's why it's quadratic. The other example, and it can be negative, negative 2x squared plus 2x equals 4x plus 6. This entire thing is an equation, okay? Lots of times just because it equals 0, 0 is just a number, just like how 4x plus 6 is a number. So it doesn't matter what's on either side, as long as the highest exponent on either side is not more than 2. Now, it gives two examples of not quadratic. The first one is 5x plus 3 equals 2x. There is no to the power of 2, so actually this equation is linear. It's a line. It's not quadratic. And the other example is negative 5x cubed plus 4x plus 3 equals 0. Because 3 is the highest exponent, it's called a cubic equation. It's not called, it's not a second degree. It's not a parabola. All right, so the number of real roots or solutions a quadratic equation has in standard form is either going to be 0, 1, or 2, okay? So real roots or solutions just means crossing the x-axis. How many x-intercepts does it have? That's the answer, okay? That's what a solution or a root is. So when you have parabolas, you can either never cross the x-axis. Have a look at this parabola, okay? It has no real roots because this parabola never touches the x-axis, so you don't have any roots. Now you might have 1 because it might touch exactly at its vertex, and so just touching 1, or it might have 2 like the ones we've done so far where it crosses the x-axis twice, okay? There's no other way to have the answers. And then it says that you can always use a graph to determine how many roots a quadratic equation has, and a graph will give you an approximate value of a solution. So sometimes the quadratic equation or the parabola goes through the x-axis at a really nice, easy to read point. Sometimes it doesn't, and that's where graphing technology can come in really handy. So this first example we have, here I've got a picture of, remember the graphing calculators? We're not using them in this class. We're actually going to go online and use this graphing calculator. But this is what the window used to look like. And that's what we would have done had we been in a normal classroom and not this flipped classroom. But it says, example number 1, solve this quadratic equation by graphing and verify your solutions. So here is this graph, okay, this parabola. This is about the approximate vertex. It's a maximum. And you can tell because look how my opening A is negative 4.9, so my parabola has to open down. So when it asks you to solve, it's asking you where does this cross the x-axis? And so on this graphing calculator, this would be 1, this would be 2, this would be 3. So it's not quite at half, so it looks like approximately, I don't know, maybe 0.3-ish, 0.4-ish. And if this is 3 and that's 4, like maybe around 3.7-ish. I'm estimating, okay? I'm just looking at it and eyeballing it. That's not really going to cut it. We have to graph it. So you're going to go to this graphing calculator here. You're going to type this in, negative 4.9x squared plus 19.2x minus 5.2. So the way this graphing calculator works is you're going to stick your cursor right there, press negative, and then I need 4.9. And then for an x, you have to click here, and then to square it, you click there, okay? So negative 4.9x squared plus 19.2x minus 5.2. And then if you want to play, you can use this plus and minus button. I think you can use your mouse. Yeah, I'm using my mouse scroll button. Because remember, what we're interested in is right here and right there. And this one is lovely. You could just stick the cursor right there. And so my x-intercepts are 0.293. So actually, I didn't do too bad of an estimate. And the other one, just move your cursor over there, is 3.626. So my answers, you would say here, x equals 0.293. It doesn't say how many decimals, so we might as well give them all. And x equals 3.626. And that's the answer. Okay, solve. That means if I took this number, 0.293, and I plugged it in for x and I squared it, and I multiplied it by negative 4.9, if I plugged it in here again and multiplied it by 19.2, added them together and subtracted 5.2, I would get 0. And the same 3.626. So it's what makes this equation true. And the way that you can tell is you graph it and you look at where does it cross the x-axis. So it would be very difficult right now to calculate that unless you know how to use the quadratic formula, but we don't yet. So we could solve them by graphing. And so we can use this online graphing calculator. Okay, so that's how you do these kinds. All right, the next example has two things on either side of the graphing, or sorry, either side of the equal sign. And again, here's a picture. So the top graph is 2x squared minus 5x plus 3. And the other graph is 3x times 2 minus x. So this one clearly opens up because my a is greater than 0. Now this one starts with a 3, but this one isn't in ax squared plus bx plus c form. Has to be in that form. Plus c, that's the squared. So if I took this 3x and multiplied by 2, I'd have 6x. If I took this 3x and multiplied by negative x, I'd have negative 3x squared. Or I'd have negative 3x squared plus 6x. So hopefully now it makes more sense why the second graph opens down. So my solution, I'm still looking for x. And these two graphs intersect here and here. So what I'm interested in is what is the x value here and what's the x value here. Once I know these two x values, it means that I could plug them in for every single x, and it would make the left side equal the right side. So let's go to our graphing calculator again online. Get rid of this one and type in the two equations. You're going to type them in separately. So the first one's 2x squared minus 5x plus 3. And then just move your cursor down to number 2. That one's going to be 3x bracket 2 minus x. And there's my second graph. And so look at here, they're showing you that the first graph is orange. So here it is. The second graph is black. Here it is. Remember what I told you here, I'm interested in where do they intersect. And it's the x part because look, I'm solving for x. So I go to my graph, my first x. This is way easier than using the graphing calculator, by the way. It's as simple as sticking your mouse over top. So the first x is at 0.319. And notice this is an ordered pair. It's not they don't have brackets around it, but it means that the x is 0.319 and the y is 1.6. But I just care about the x. So the first value is 0.319. The other one is 1.881. So back to your booklet, my two values. X is either 0.319 or x can be 1.881. That means that I can take either of these values, I can plug them anywhere I see an x, and I could calculate the value of the left side, calculate the value of the right side, and it would be exactly the same. So typing it into an online graphing calculator, not very difficult. We'll get to graphing them by hand, but for now you got it pretty easy. All right, 7.3 is done.